Your house needs repainting. You already know this because the south side is peeling again. The last time you hired it out, scraping, sanding, priming, 2 coats, the bill was between $3,000 and $8,000. The painter told you the same thing every painter tells you: see you in 5 years. Over 60 years, that cycle repeats 8 to 12 times. Add rot repairs. Add 1 full siding replacement. Total cost for a 2,000 square foot home with painted wood siding from $55,000 to $70,000. Not for the house, for the skin of the house. The same house clad in charred cedar, wood you burn with a $30 propane torch before you hang it, costs about $12,000. Once, no repainting, no chemical treatment, no replacement cycle. Structures in Kurashiki, Japan, have stood with this siding for over 300 years. In 2017, a house clad in charred cedar survived the Tubbs fire in Calistoga, California. Fire came directly up the side. The charred surface held. Only the resin on the back of the planks melted. The U.S. architectural paint market generates $15.5 billion a year. The vinyl siding market generates $7.4 billion. Pressure-treated lumber generates $10.1 billion. A siding product that never needs repainting threatens every one of those revenue streams simultaneously. Here is how it works, what it costs to do yourself, and exactly who profits from making sure you have never heard of it. The siding industry sells you a number: installed cost per square foot. Vinyl is $4 to $8 per square foot. Painted wood is $8 to $15 per square foot. Fiber cement is $5 to $14 per square foot. That number gets you in the door. What it hides is the 60-year total cost of ownership, the figure that includes every repaint, every rot repair, every full replacement, every pest treatment over the life of the house. Vinyl siding lasts 20 to 40 years. It cannot be repaired. A single damaged panel means swapping the panel, hoping the manufacturer still makes that color. Over 60 years, expect 1 to 2 full replacements. Lifetime cost is $25,000 to $50,000. And when vinyl burns in any house fire, it releases hydrogen chloride, formaldehyde, and dioxin, known carcinogens. Firefighters have in some cases let vinyl-clad homes burn rather than risk the exposure. Painted wood siding lasts indefinitely if you repaint it every 3 to 7 years at $3,000 to $8,000 per event. Here's the part that should make you angry. Preparation, scraping, and sanding the peeling paint accounts for 60% of the labor cost. You are paying thousands of dollars to remove the last coat so you can apply the next one. Over 60 years, 8 to 12 repaints push painting costs alone to $40,000 to $78,000. Add rot repairs at $4 to $13 per square foot. Add mold removal at $15 to $30 per square foot. Add at least 1 full replacement. The paint is not protecting your wood. The paint is a subscription. Now look at what fire does. Wood is 3 polymers. Cellulose makes up 40 to 50%. It provides tensile strength. Hemicellulose is 25 to 35%. It binds fibers together and contains the sugars that attract every organism that destroys your siding. Termites eat it. Fungi feed on it. Bacteria colonize it. It absorbs water. Hemicellulose is the reason you repaint. The third polymer, lignin, at 15 to 35%, is the structural glue that holds the whole matrix together. When you char wood, a process called pyrolysis, the 3 polymers decompose in sequence. Hemicellulose goes first, between 220 and 315 degrees Celsius. It is the most thermally reactive component and the one that feeds every biological attacker. Cellulose follows at 315 to 400 degrees Celsius. Lignin is the most resistant, maintaining structural integrity across the entire charring range. Think of it this way. Charring strips a house down to the studs and removes everything that rots, except at the molecular level. The fire burns away the buffet. What remains is the lignin skeleton coated in a 2 to 5 millimeter layer of pure carbon. And carbon changes everything. Carbon is non-polar. Water molecules are polar. They bond to surfaces that carry an electrical charge. Carbon carries none. Water hits the charred surface and has nothing to grab onto. It beads up. It rolls off. Maya Kimalainen, and Lauri Rautkari at Aalto University in Finland, the most prolific charred wood research group in the world, published 7 papers between 2017 and 2022. They documented 24 to 56% reductions in water absorption depending on species and charring method. One of their studies found contact charring equal to or better than a double layer of acrylic paint on primer for keeping water out. Pause on that. Fire outperforms 2 coats of paint. Insects cannot eat carbon. There is no cellulose left to consume. Fungi cannot colonize it. The surface carbohydrates they need are gone. And ultraviolet light, the force that degrades every painted surface you have ever owned, is absorbed by the black carbon layer rather than penetrating the wood beneath. Sita and colleagues measured this in 2023. Charred samples showed a color stability index of 9 or less after 2 full years of outdoor weathering. Untreated wood scored 60. The charred surface is 6 to 7 times more UV stable. Now look at the 2 approaches side by side. Paint sits on the surface. It is a barrier that degrades under UV, cracks under thermal cycling, peels, and then admits water behind it, where the water accelerates the very rot the paint was supposed to prevent. Charring transforms the surface itself. There is no coating to fail because the protective layer is the wood. The carbon does not peel. It does not crack. It does not need reapplication every 5 years. The fire did it once, for free. Humans figured this out before they had written language. The Clacton spear point, found in Essex, England, dates to roughly 400,000 years ago. It is a fire-hardened wooden tool. It is the oldest evidence that people understood how fire changes wood's mechanical and biological properties. Vitruvius, the Roman architect, recommended carbonizing wood to extend the service life of bridges and fortification fences in De Architectura, written in the 1st century BC. This is not folk practice. This is engineering specification, documented in a civilization that built infrastructure to last centuries. Leonardo da Vinci went further. In the Madrid Codex II, folio 87R, he wrote that wood will be better preserved if stripped of bark and burned on the surface than in any other way. Leonardo did not invent this. He recorded what builders already knew. Across Britain, France, Termites, Germany, and Scandinavia, fence post charring was standard practice for centuries. Scandinavian shipbuilders fire-bent and preserved boat lumber across Denmark, Finland, Iceland, Norway, and Sweden. Early Iron Age sites in South Africa, at Ndondondwane in KwaZulu-Natal, from roughly 1,200 years ago, show charcoal and burning used in construction. On separate continents, separated by thousands of years, builders arrived at the same answer. That is not coincidence. That is physics. But only one culture systematized it into architectural cladding. In Edo period Japan, between 1603 and 1868, the city of Edo, modern Tokyo, recorded nearly 1,800 fires. 49 of them qualified as Great Fires. The Great Fire of Mereki in 1657 destroyed 60 to 70% of the city and killed an estimated 100,000 people. January through April accounted for 70% of all Great Fires. The merchant class, the lowest rung of Edo's rigid social hierarchy, needed fire-resistant cladding for their wooden townhouses and storehouses. Those who could not afford stone or stucco turned to charred wood. Nakamoto Forestry's research indicates the technique transferred from boat building. Ship hulls were charred as a preservative before launch. The same chemistry that keeps a hull from rotting in salt water keeps a wall from rotting in rain. The wood of choice, Cryptomeria japonica, Japanese cedar, has lifespans exceeding 1,000 years. Prior to the 1970s, Yakisugi, the Japanese name for this technique, was known as a poor man's building material. It was installed on storehouses in industrial zones and on residences in areas not easily visible to passers-by. It was the cheapest fire-resistant cladding available in Japan. Remember that phrase? Poor man's building material. It matters later. The structures survive. Saga Toriyamoto in Kyoto has maintained charred wood gables for nearly 400 years. The Kurashiki Bikan Historical Quarter in Okayama Prefecture contains 17th century kura, storehouses, still standing with yakisugi, combined with white lime plaster. The Yoshi residence in the Takahara Conservation Area in Hiroshima Prefecture dates to 1691. Ina fishing village on the Kyoto coast has funaya, boathouses, with decades-old charred wood lining the entire inlet. Shotoshima Island has warehouses approximately 100 years old, with the original charred cladding intact. One more thing the charring process creates: a distinctive cracked pattern that looks like alligator skin. This is not decorative. Spring wood, the soft, fast-growing part of each annual ring, and summer wood, the dense, slow-growing part, contract at different rates during charring. The cracked texture that results increases surface area for water runoff. It is functional drainage geometry built into the surface of every board. Now the science. This is where honest reporting matters. The research picture is more complicated than the marketing. Laura Hasberg, Samuel Zelinka, Amy Bischel, and Grant Kirker at the USDA Forest Products Laboratory in Madison, Wisconsin, published the most comprehensive study in 2021 in the journal Forests. They tested 31 commercially available Yakisugi band specimens and found that the Yakisugi band process did not systematically improve the flammability or durability of the siding. The results were species-dependent. Cypress showed the most benefit. Charring white oak and hemlock actually increased peak heat release rates. That sounds damning until you understand what it actually means. The technique is not magic that works on any species of wood. It is a specific chemical transformation that works best on specific species at specific char depths. Japanese practitioners knew this. They used only Cryptomeria japonica with a high-heat triangular flue method that generates far more energy than any handheld torch. A propane torch on random Home Depot lumber is a different process entirely. And here is the proof. Nakamoto Forestry's Suyaki charred Japanese cypress using their controlled process, tested to ASTME 84, Class A. That is a flame spread index of 0 to 25, the highest residential fire rating available. Untreated cypress rates. Class C flame spread index 76 to 200. The product that was set on fire is now the most fire-resistant wood siding you can buy. On termite resistance, Chris Peterson at the University of Georgia published a study in 2008 in Entomologia Experimentalis et Applicata and found that charring alone did not prevent subterranean termite infestation. But S. Nami Kartal at Istanbul University Sarapasa, working with the USDA Forest Products Laboratory, published a follow-up in 2023 showing significantly less weight loss in charred specimens treated with oil. Deeper charring plus an OIL finish outperforms charring alone. Kim Alainen and her team at Aalto University measured decay fungi in 2022. Mass losses dropped from 56 to 60% in untreated wood to 23 to 32% in contact charred wood. Not total immunity. A 40 to 60% improvement without a single chemical applied. The science does not say this technique fails. It says species matters, char depth matters, oil finish matters, method matters, which is exactly what 300 years of Japanese practice already demonstrated. Translate that to your wallet. Annual US termite damage and control costs total approximately $5 billion. Termite damage is not covered by standard homeowners insurance. Average repair cost per incident is $3,000, with a range up to $15,000 or more. A proper charring technique with an OIL finish reduces that biological attack surface by 40 to 60%, with zero chemical treatment, zero annual pest control contracts, zero recurring cost. Charred wood siding faces no specific prohibition in the IBC or the IRC. It falls under Generic Wood Siding Provisions, IBC. Chapter 14 and IRC, Section R703. Products with Class A or Class B. Flame spread ratings are code compliant for exterior cladding, including in California's wildland-urban interface zones. The barrier is not a ban, it is a classification gap. The AWPA writes preservative treatment standards that building codes reference. Those standards define treated wood exclusively through chemical pressure treatment, chromated copper arsenate until the 2004 phase-out, then alkaline copper quaternary, copper azole, and micronized copper azole after that. There is no AWPA standard for thermal treatment. Charring does not exist in their framework. No standard means no prescriptive code pathway. No code pathway means every charred wood installation requires a local building official to invoke IBC. Section 104.11, the alternative materials, design, and methods of construction provision, at their personal discretion. A documented response on a building code forum to a homeowner asking about Yakisugi said, "You saw this on TV, didn't you? This is not conspiracy. This is a system designed around chemical treatment, where anything outside that framework forces individual officials to stick their neck out, and the system self-perpetuates. Follow the chain." The AWPA writes treatment standards. Building codes reference those standards. Code officials enforce those standards. Products not covered by those standards require expensive ICC evaluation service reports, testing that small producers cannot afford. The market stays empty because small producers cannot get tested. Code officials never encounter the product because the market is empty. And because officials never encounter it, they default to skepticism when someone walks in with a charred board. Each link reinforces the next. Nobody has to coordinate. The loop runs itself. Now look at who benefits from the loop staying closed. Sherwin-Williams reported $23.1 billion in revenue for fiscal year 2024, their 40th consecutive annual dividend increase. Their residential repaint segment is growing at high single digits annually. Every house that stops repainting is revenue. Sherwin-Williams loses permanently. The U.S. pressure-treated lumber industry generates $10.1 billion a year. Koppers Holdings alone reported $2.09 billion in fiscal year 2024 revenue. Argzada AG, formerly Lonza Wood Protection, has been in the wood preservation business for over 120 years. Cornerstone Building Brands, which owns Ply Gem, was taken private by Clayton Dubilier and Rice in 2022 at a $5.8 billion enterprise value. They are the largest exterior building products manufacturer in North America. The global vinyl siding market is $7.4 billion. Vinyl commands 38 to 41% of the U.S. siding market and 76% of the market in the Northeast. Combined, the industries that depend on you replacing, retreating, or repainting your siding represent more than $30 billion in annual revenue. A one-time product with an 80-year lifespan and zero maintenance threatens every one of them simultaneously. Every dollar you spend on charred cedar is a dollar that never enters any of their replacement cycles again. Now try to get an FHA or VA mortgage on a house clad in Yakisugi. The lender calls the appraiser. The appraiser sees a non-standard material. FHA and VA requirements specify that the structure must provide acceptable durability and economy of maintenance, but the appraiser has never encountered Yakisugi. The appraisal flags it. The lender hesitates, the loan stalls. Insurance classifies it as generic wood siding, the same premium category as untreated pine, even though a Class A Yakisugi wall outperforms vinyl in fire testing. The product that survived the tub's fire sits in the same risk classification as the product that releases hydrogen chloride and dioxin when it burns. HOA architectural review committees add another layer. The Vinyl Siding Institute has documented how local aesthetic mandates and material bans affect alternative cladding. In Texas in 2019, state legislation had to explicitly prohibit local governments from banning polymeric exterior products, confirming that material-specific bans were already happening. Black charred wood triggers aesthetic resistance in communities with color restrictions. Yakisugi does not appear on approved materials lists. And then the most effective barrier of all, the one that requires no regulation, no lobbying, no code manipulation, price repositioning. A technique developed as a poor man's preservation method now commands $13 to $27 per square foot, installed from commercial suppliers. Nakamoto Forestry's material runs $5 to $13 per square foot. Resawn timber starts at $8. Delta Millworks charges $10 to $15 or more for custom work. A 2017 New York Times feature cemented the luxury positioning. The gap between DIY cost, $4.50 to $9 per square foot, and professional installation at $13 to $27 per square foot is a 2 to 5 times markup. Price a poor man's material into the luxury market, and it never reaches the people who need it most. The homeowner spending $8,000 every 5 years on repainting has never heard of it. Not because it was banned, but because it was made to look expensive. The traditional Japanese method uses 3 boards. Select 3 of equal length, 1 by 8 or 1 by 10, 6 to 10 feet long. Bind them together with wire to form a triangular chimney with the faces turned inward. Stand the triangle upright on a fireproof surface in a wind-protected outdoor area. Crumple newspaper and tinder at the base and light the fire. What happens next is violent. The chimney effect draws flame upward through the interior with a roaring whoosh that sounds nothing like a campfire. All 3 faces char simultaneously and evenly to a depth of 3 to 4 millimeters in approximately 2 to 5 minutes. Nakamoto Forestry tried this method themselves and noted it took about half a day of practice to get consistent char end-to-end and edge-to-edge. The flue generates far more BTU energy than any handheld torch, which is why Nakamoto explicitly states that a handheld torch cannot be used to make true Yakisugi, because it does not have sufficient BTU energy to burn off enough hemicellulose. That is an honest limitation. A torch-charred board is good. It is not identical to the commercial product, but it is dramatically better than untreated wood, and here is the path most North American DIYers will take. Start with Western red cedar. It has natural rot resistance and straight grain, the preferred North American substitute for Japanese cedar. Use kiln-dried or air-dried stock at 10 to 15% moisture content. Never char pressure-treated wood. The chemicals concentrate in the smoke, and the fumes are toxic. Sand or round off any hard edges to prevent uneven burning. Use a propane weed burner rated 340,000 to 500,000 BTUs. Harbor Freight sells one for about $30. Hold the torch 4 to 6 inches from the surface. Move slowly in the direction of the grain. You are aiming for deep, uniform black, with visible alligator skin cracking at 3 to 5 millimeters of char depth. Spring wood burns faster than dense summer wood, so do not rush through the summer veins. Expect 5 to 10 minutes per 8-foot board. The flame crawls across the grain like a living thing. The surface transforms from tan to jet black in seconds. Cedar produces a sweet, almost incense-like aroma, distinctly different from construction smoke, with a sharpness of burning resin underneath. Pops and snaps punctuate the steady hiss as moisture escapes cellular cavities. Cool the board. Spray it with water immediately to stop the burn precisely, or let it cool naturally for 5 to 10 minutes. Then brush with a stiff stainless steel wire brush in the direction of the grain only. This removes the soft, burned spring wood and leaves the harder late wood standing. Minimal brushing gives you the deep black suyaki look, the most protective surface. Heavy brushing reveals lighter topographic texture where the grain-con contrast shows through. Finishing is optional. Boiled linseed oil, $15 to $25 per gallon, covers 300 to 500 square feet. Tung oil runs $30 to $60 per gallon and covers 300 to 400 square feet. Many traditional Japanese installations are left entirely unoiled, and in Japan, the weathering that develops over decades is valued rather than repaired, the opposite of Western maintenance culture. Now, spray water on a freshly charred surface and watch it bead up and roll off like mercury on glass. The wood that needed repainting every 5 years now repels water on contact. That is the moment you understand what fire did. Here is what you spend. Propane weed burner, $30 to $60. Propane tank refill, $15 to $20, enough to char 200 to 400 square feet. Wire brush, $8 to $15. Western red cedar boards, $4 to $8 per square foot. Boiled linseed oil, $15 to $25 per gallon. Safety gear costs $55 to $110. That includes leather gloves, goggles, a respirator, and a fire extinguisher. Total tool investment is $250 to $400, not including lumber. All-in do-it-yourself cost is $4.50 to $9 per square foot. A typical 2,000 square foot house needs 1,500 to 2,000 square feet of siding. At a charring rate of 15 to 25 square feet per hour, expect 60 to 130 hours of charring, 8 to 16 full work days, plus 40 to 80 hours for installation. It is labor, but that labor replaces 60 years of repainting. Nakamoto Forestry ships 650,000 to 810,000 square feet of Yakisugi per month from their facilities in Hiroshima, Japan, with North American distribution out of Portland, Oregon, established by William Balek. Their Suyaki product holds its deep black for 40 to 50 years. Their Gendai, wire-brushed once, lasts approximately 75 years without maintenance. The Hatfield Marine Studies building on the Oregon coast used 35,000 square feet of Nakamoto siding, designed to withstand a magnitude 9 earthquake and a major tsunami. And in Calistoga, California, during the 2017 Tubbs fire, a house clad in Nakamoto Yakisugi took direct fire exposure up the exterior wall. The charred siding did not ignite. The resin on the unexposed back face melted. The boards themselves held. The house survived. For code compliance, IBC Section 104.11 allows alternative materials at the building official's discretion. Products with ASTM E84 Class A ratings are WUI compliant. Oregon, Washington, and California are the most receptive jurisdictions, states with both sustainability culture and established Yakisugi supplier presence. Owner-builder exemptions vary by state, but can provide additional flexibility. Over 60 years, painted wood siding costs you $55,000 to $70,000. Vinyl costs $25,000 to $50,000. DIY charred cedar costs $12,000. The difference, up to $58,000 per house, flows directly into the recurring revenue of a siding, paint, and chemical treatment industry worth more than $30 billion a year. You were never supposed to learn that fire does for free what those industries charge you for every 5 years. Your siding is a subscription. The paint cycle, the chemical treatment cycle, the replacement cycle, each one was designed to bring you back. Charred cedar cancels all three simultaneously. That is why you have never seen it at Home Depot. Yakisugi was a poor man's building material. The cheapest fire-resistant cladding in Edo period Japan. 300 years later, Western markets charge $27 a square foot for it. The people who need it most, the ones writing $8,000 checks to their painter every 5 years, have never heard of it. Charred cedar handles your walls, but every month you are still paying to heat the air inside them. A Korean floor system, on DOL, heated entire palaces for centuries using a single fire at one end of the building. No furnace, no ductwork, no electric bill. The Romans built the same system independently. Exposed ruins across England prove it worked in cold, wet climates 2,000 years ago. Today, radiant floor heating is the most efficient heating method engineers have ever measured. And in most American jurisdictions, building code still requires a forced air furnace whether you need one or not. That archive opens next.